Alright, so let's look at how to convert a complex number from one form to another. Now recall that the rectangular form of a complex number is written as z is equal to a plus bi. So this is the rectangular form. And then the polar form of a complex number is written as z is equal to arrow open bracket cos theta plus I sin theta. So this is the polar form. And also recall that the exponential or Euler's form of a complex number is written as z is equal to arrow exponential I multiplied by theta. So this is the exponential form. Where a is the real number, r is the modulus of a complex number, and then theta is the angle or argument. Now, theta can be expressed in degrees. Theta can be expressed in degrees or pi. Theta can be expressed in degrees or pi. Now note this, 1 pi is equal to 180 degrees. Alright, so let's take an example for proper understanding. Alright, so if z is equal to 3 plus 2i, while looking at it, you will know that z is in the rectangular form of a complex number. So if we are asked to convert z from rectangular form to polar form and Euler's form, how do we go about it? Now, first of all, let's identify the given terms. A, which is the real term, is 3. The real term is the term that doesn't have I attached to it. And then B, which is the imaginary term, is positive 2. The imaginary term is the term that has I attached to it. Now, our first task here is to look for the modulus of the complex number. And modulus of a complex number R is equal to square root of a squared plus b squared. Now let's substitute the given parameters. So we have R is equal to square root of 3 squared plus 2 squared. Three squared is 9, and then plus 2 squared is 4. So therefore R is equal to square root of 9 plus 4 is 13. All right, so our next task is to find theta. Theta, which is the angle, is equal to tan inverse of B all over A. So now let's substitute the parameters. So theta is equal to tan inverse of B is 2 and A is 3. So theta is equal to tan inverse of 2 all over 3 is 0.67. So therefore, theta is equal to, if you punch this in your calculator, tan inverse of 0.67, it would give you 33.82 degrees. Alright, so since we've gotten the modulus of a complex number and theta, let's now begin the conversion. We'll convert from rectangular form to polar form first. Remember that z is equal to 3 plus 2i. Z is given in rectangular form. So to convert to polar form, the polar form of a complex number z is equal to arrow open bracket cos theta and then plus I sin theta. So this is the polar form of a complex number. So we've gotten r and we've also calculated for theta. So now let's substitute into the equation. So z is equal to, from our previous calculation, r gave us square root of 13, open bracket, cos, and then the value of theta is 33.82 degrees, and then plus I sin 33.82, and then you attach degrees. All right, so we've now converted from rectangular form to polar form. All right, so let's convert from rectangular form to Euler's or exponential form. The formula for exponential form is z equal to arrow exponential I multiplied by theta. So if we substitute the calculated values, we will have z is equal to r, which is the modulus of a complex number, is square root of 13, and then exponential I multiplied by theta gave us 33.82 degrees. So therefore, z is equal to square root of 13 exponential 33.82i. So this is our final answer. Alright, so this is how to convert from one form of a complex number to another form of a complex number. Alright, if you've not subscribed to my channel, kindly subscribe now. You can also share this video to your colleagues, and also don't forget to leave a comment in the comment section. Thank you for watching.